Hello everyone, and welcome to today's workshop on climate change. So for the Copernicus WEkEO service, my name is Gail Starbik. I'm a training officer at Mercator Ocean International, and I'll be your host for today. As you know, today is the second day of this training, and today is the practical session using Copernicus data available on WEkEO. Before we start, let's quickly go over some house rules and guidelines to make sure you enjoy this webinar. First, we ask you not to use the chat that you see on your right-hand side for your questions. You can use it for small talk or to say hello to us. But if you have a more technical question or content-related question, we invite you to use the dedicated Q&A section that you can find on the website. So you will see the Q&A button on the top bar of your screen, and simply click on it to open the dedicated space where you can ask our speaker your questions. And while you're on this section, you will also see the quick survey of the training workshop, so feel free to fill it out anytime during the session. And concerning the agenda of today, we will have 4 demonstrations. The first one being by David Bina from the WEkEO user support. You will start with a presentation of the WEkEO visualization tool, the WEkEO Viewer. And then we will move to the 3 tutorials that our experts from Novelties prepared for you today. And perhaps some of you even had time to practice before the session. So we will start with the Jupyter tutorial with Alexandre Omerin. Then we will go to the QGIS tutorial with Daria Andrievska, and finally we will go to the RStudio tutorial by Simon Millet. So I hope you had time to practice, and let's dive into the WEkEO Viewer now. David, whenever you want, you can start your presentation.
Hi everyone, thank you Gail. So I'm here today to present the WEkEO Viewer. Let me share my screen first. So I'm David from the WEkEO user support, as Gail said. And today we will see the WEkEO data viewer, and there are 2 viewers. In fact, there is the light data viewer and there is the expert data viewer. Do you see my screen now?
Okay. Yes, it's okay.
Okay, because I don't see the green thing. Okay. So here we are on the WEkEO homepage at wekeo.copernicus.eu. And here on the service and tools menu, you can see the different tools of the WEkEO. And the first one is the data viewer, but there is another way to see these tools is by signing in. So you can create an account when you click on this button here on the bottom right. You have create an account. And you just have to fill in this form to create your account. Then you will receive an email to confirm the creation of your account. But here, obviously, I already have a WEkEO account, so I sign in. And now I'm reaching the WEkEO dashboard called My WEkEO. And we see all the WEkEO tools that are at our disposal. So here we have the data viewer, and I will do my presentation on this tool today. You can also open directly the data catalog here. So the data catalog is contained in the expert data viewer, as we will see in a moment. Then here on the right, we have the WEkEO workspace, which basically redirects you to the WEkEO Jupyter Hub interface, where you can run some present notebooks and where you can use available environments with pre-installed packages like the Harmonized Data Access, which is a package to download WEkEO data, and other tools to download and do some post-processing to the WEkEO data. Here we have the Jupyter catalog, which is also a place where you will find all the WEkEO notebooks that cover different use cases. Then we have the WEkEO Drive, where you can store and share your work with your colleagues. You have up to 8 gigabytes. Then you can upgrade your plan to get access to more advanced tools. And from your dashboard, if you scroll a little bit, you have access to the Help Center, which is a collection of useful articles where you can search for and find valuable information. And I will show the Help Center at the very end of today's presentation. So now I will click here on the Data Viewer, on the Go button. When you reach this tool for the first time, uh, you will reach the Light Data Viewer that you can see here on the top right. So the Light Data Viewer is a quite recent new viewer. And a really recent new feature also is this guide tool. So basically you can, it will guide you through the functionalities of the Light Data Viewer. So you can click on Let's Go here, and then it will show you, and you can interact during this guide tool to discover all the functionalities of the tool. But basically, it will show what I'm going to show you today. So I will close it for now. So when you are on the Light Data Viewer, you can see here on the left the pre-selected key variables from different Copernicus services. So we have the Copernicus Marine, yes, Copernicus Land, Atmosphere, Climate Change, and Sentinel missions. You can open a tab by clicking here on the arrow. So here the default layer is the temperature, but I could click and I can click on velocity to visualize the velocity. And then there are some other variables. So I won't click on all of this, but for Copernicus Land, it's more about vegetation and snow, etc. Atmosphere, you have this kind of variables on the atmosphere, obviously. Climate change, you have these variables, and Sentinel, you have also, so you have 4 variables, pre-selected variables for each service. Then you have the Talk to an Expert button, which opens the widget chat that is accessible from any page of WEkEO at the bottom right. But I will speak about this widget chat just at the end of my presentation. And then you have this settings button where you can hide and show the base map and hide and show the coastline and reference features. You can also change the units and you have the credits of the tool. So when and once you have selected a variable, we can see the full name of the variable here at the top with the unit and the date where we are visualizing the data. Speaking of the date, we have here at the bottom the timeline. So you can click on this time bar to pick another date, and the data is automatically updated on the viewer. You can zoom in and zoom out, by the way, on the map by scrolling with your mouse, and you can grab the map can move on the map by grabbing it, like so. So here I have picked another date. For some variables, like here the temperature, we have also the depth scale. So I can go around 2000 meters, for example. Sometimes we have to wait a few seconds for the data to be updated. And normally we will start to see the bathymetry around the continent. Okay, maybe it's my connection, maybe it's because we are live, so I have some lags, but okay, so now we can see the bathymetry at 2000 meters. But let me go back to the surface, around the surface. Okay, here on the right, we have the color bar with which the variable is displayed. And we can click on this cog icon to change the color bar, like this. We have here on the top the opacity, so we can decrease and increase the opacity. And for some variables, you can also change the minimum and maximum value. You can also, here at the bottom right, change the projection. So we are here by default with the equatorial projection, but we can choose between polar and south projection also to work with, to better visualize, let's say, the Arctic and Antarctic area. So here is the Arctic area. I will go back to equatorial. And I think that's it for the Light Data Viewer. So basically, it's a starting point for beginners to start exploring key variables of Earth observation data. But then we can go, and I will go on the Expert Data Viewer here. And from there, I can access the full WEkEO catalog and not only visualize data, but also download them. So here on the left, as the light data viewer, we have the layers, so the variables we are displaying, visualizing. So there are two default layers, the normalized difference vegetation index from Copernicus land and the seawater salinity from Copernicus marine. But if we click on this plus icon, we open the catalog. So here on the right, we can see that there are more than 400 datasets. We can, if we want, we can scroll from top to bottom to find our products of interest. We have here the name of the dataset. Just below, we have the temporal extent, and then we have the extract of the description of the product. There is a thumbnail showing the an extract of the data, what the data is about, what the data is about. Here is the icon, this slash I icon. We can know that this dataset is not visualizable on the map. When a dataset is visualizable on the map, we have this icon showing also the number of variables contained in this dataset. And the star is to add this dataset to your favorites that we find here on the left. Speaking on the left, we advise to use the filters here to search for your product of interest because there are many datasets. So here, if we click on viewable, basically we will find only the dataset that are viewable on the map. So that can be really convenient. Then we have some featured dataset, the favorites that we have added. Then you can find the different Copernicus services, the different platforms, also different sensors, and the area and other useful tags to find your product of interest. So for today's presentation, I think I will go with the Sentinel-2 because if I'm not mistaken, Daria will take this dataset during this QGIS presentation. So I will take this one. When you are here, you can click on details to open the description page of the product of the dataset. When you are here on this page, you have here on the left the thumbnail. Then you have the temporal and geographical extent. You can click on Add to Map to add the variables on the map. I will do it at the end. And then for those who are interested in visualizing the data via the WebMap service protocol, you can click here and you can copy the WMS link. Okay, but now I will go back to the description. For some datasets, you will have some use cases present here at the top. So these are use cases that are using these datasets. So it can give you some ideas or inspiration to know how to use these datasets. And if you click on this use case, you will reach a page on the WEkEO website with more details on this use case. Then we have an abstract, which is a description of the dataset, what we will find in it. And then we have some other parameters like the dataset ID, which is quite useful when we want to download data programmatically, or when you want to talk with us if you have some issues or questions, so that we know which dataset you are talking about. So the dataset ID is quite important. And then you have some other resources and metadata. Okay, so now I will click on Add to Map. And when you click on Add to Map, if there are several variables in the dataset, they are listed here. So we can add a variable. I will, for example, pick the normalized difference vegetation index. Okay, so now it is added here on the layers panel. And as you can see, there is a sentence saying zoom in to view on the map. So basically the Sentinel data, you need to zoom in to the map to be able to view the data. And if you click on this button, normally the zoom level is enough to start seeing the data. If not, you can zoom in a little bit more. Also, here on the left, you can hide and show some layers. So I will hide this, or even you can also remove some layers. So I will remove this one. But just to show you, we can hide and show a layers with the eye icon here. Okay, I will hide this one. And because I know that the Sentinel data is in the land continent, sometimes it's better to hide the base map. So like in the light data viewer, we can click here on the bottom right on settings and hide the base map. So I will zoom in a little bit and I will pick another date. Okay, so we start to see some data. Maybe I will unzoom. Let me choose a date where we can really see data. Okay, so because it is a Sentinel satellite, the data is displayed like tiles, with tiles, as we can see here. Okay, so now let me speak about the buttons we have here to customize how the data is displayed. Maybe I will just show the sea water salinity one back, just to show you that you can click here on the log. So it's not for every variable, of course, but when you can click on the log to display the data into a log scale. Then if you click on this cog icon, it's like the light data viewer, you can decrease the opacity and you can change the color map and you can change the minimum and maximum value. Then if you click on this button, it's really convenient because uh, it, it allows us to pick another variable inside this product. So for example, here I have the seawater salinity, but I could pick the temperature, for example. So I don't need to open the catalog once again to add this variable to the map because it's inside this dataset. Okay, and maybe just to show you another functionality, if you pick a variable that consists in vectors, we have here this new button that appeared to show the vectors of the variable. So we are now able to not only see the amplitude of the values, but also the directions with the arrows. Okay, so I will go back to the default salinity. The I button simply opens a new the description page of the datasets. And then we have the download button here, and I will show you that in a moment. Before that, I just want to, so let me zoom in a bit on this Sentinel-2 data. We have here, maybe I will go like this. We have here the object. So as in the light data viewer, we can also change from equatorial to polar north or solar south projections. We can also place a point like this, so we can see the coordinates. Also, if you place a point, for example, in a variable in the ocean like this from Copernicus Marine, you will see these graphics that automatically is displayed and that is showing the time series of this variable. Then let me go back maybe like this. We have the measure tool to measure the distance between 2 points, basically. And maybe the most important tool here is this set AOI parameter that allows to draw a bounding box like here. And then afterwards, we will be able to download data only inside this bounding box. And just to show you, because I'm here on the bottom right, here we have the help button, so the equivalent of the talk to an expert button from Light Data Viewer. Okay, and I will speak about that just at the end. And then the settings that I already have opened to show and hide the base map, and same for the coastline and reference, the units, the credits, etc. Okay, so let's say that I'm interested in the bounding box and that I want to download data inside this bounding box for the Sentinel-2 data. So I can click here on this button, which opens this download canvas, where we can see at the very top that only the fields that are marked with an asterisk are mandatory. So if there is an asterisk, you don't need to specify the parameter. And basically, we would recommend to first start with a pretty large query. So don't put too much constraints on your query at first, at least, because sometimes if you define too many parameters, the constraints are too many and it can yield to zero results. So for your first query, we recommend to only define the mandatory parameters. Here, the bounding box is not mandatory, but just to show you, I will click on copy area from map. So I could enter the coordinates manually, but because I have drawn the rectangle, I can click on copy area from map. And now I will download data only inside this bounding box. Then I will let all the other download parameters by default, or not specifying anything. And just I will maybe choose a start and end date. Here you can click on copy from layer as well. So here on the bottom, we are on the 7th of March of this year. So I can click on copy from layer, or let's say you can click on the field to open the calendar widget and pick another date like this. So maybe I will download data between the 6th and 8th. And then we have this agreement to the license. So you can read the license by clicking on it. So the license is different for every Copernicus service. Okay, so let me check the checkbox once again. And then you have two options. We can click on show API requests to show the query. So this is helpful to download the data programmatically. So we have here on the top, we have here an article coming from our help center. I invite you to read it uh, to learn more about the HDA. So HDA stands for Harmonized Data Access. And in this article, basically we show how to use the HDA. You even have a notebook example that you can download, and then you can follow and change the query to download data via the HDA. Okay. So really, I invite you to read this article to learn more about the HDA. And here is the structure of the query is a JSON-like dictionary, and you can copy it by clicking here on copy, and then you can paste it into your script. So that's quite useful. But you can also download data directly from the viewer by clicking here on request data. So it can take a few seconds, sometimes a few minutes, depending on the server and the size of your request. And when you click on request data, you are automatically redirected to the jobs tab. So we were here on the layers tab, and here is the jobs tab. So in this jobs tab, you have your previous jobs that you have launched. You can click on this icon to show once again the query. So for example, if it was a really past job and you don't remember what was the query, it can be really useful to open it, to use it. And here we can see that this one is a new job because of this green notification. I can click on this folder icon, and here I see all the files corresponding to my query. So for each of these items, we see the size, and we can click on order. So it will ask the server to download the data, and then it can take a few seconds, and then we will be able to click on the download button. But sometimes for some query, so let me search in my past jobs. Okay, so like this one, we can see in this job that I have many items, and that's when the using the HDA becomes really handy, and that's when we recommend to use the HDA because it can be quite time consuming to click on order and the download icon for every item. So don't hesitate to, for these kind of jobs with many items, to open the query, to see the query, to copy it, and use the HDA as explained in this article. And if you have any trouble or difficulties to use the HDA, in any case, you can talk to us, the user support. We are here to help. So this one is still running. Well, it can take a few seconds and sometimes some minutes, but basically it will show a download button like here. And for this one, for example, I can click on it and the download will start. I will stop it because I am live here. Yeah, that's it for the download feature. So one last thing to wrap up this presentation is the help here on the bottom right. So maybe we can't really see it. I will go here. The help button. So it opens the widget chat. So you have here the home menu. Here on the right, you have the news feed. So it's quite useful, and I invite you to check this news. Basically, you will find the incoming WEkEO events like this one now, and the past events, and also the new features. So it can be really nice to check this news feed. Then you have this help menu. Basically, it is our help center, but here in the contained in the widget chat. So for example, if I want some information about how to download data, I can type download, and here I can find the articles related to the download. I can open the article from here, and I can even expand the window to better see it. But also, just to show you, when you are on the WEkEO website, you can click here on help and support, and you can visit our help center from here. And yeah, so that's our help center. And same as I've done in the widget chat, if I enter a download, I will see all the articles related to the download. So I will really recommend to check this our help center. Uh, it is divided into different collections. So the getting started, and then the data viewer. So for example, we have here an introduction to the expert data viewer, and also to the light data viewer here. So that's what I've shown here today, but you will see and you will read more detailed information in the articles. So I would recommend to check our help center. Let me close this tab. So here I don't know why it doesn't show. Maybe it's because of my connection. But yeah, so here you can check and search for an information if you have some troubles or questions. If you don't find the information you were looking for, you can still go here in messages and ask us a question. So please be aware that first you will be speaking to Neo. It is our AI agent. It has a lot of knowledge, and there is a high chance Neo can answer to your questions. But if he can't, don't hesitate to tell him to talk to a human agent. You can ask him in a natural language, and the conversation will be redirected to us, the human user support. So yeah, I think now that's it. And yo, so thank you for your attention.
Thanks a lot, David, for your presentation. It was really interesting, and we have a few questions for you, so we will go to that part. Okay, so the first one being, is it possible to download data products in other projections?
So if I understand the question correctly, I would answer no. We can't, for example, like here in the download canvas, we can't specify the projection. So basically, you will download the data as originally produced by the providers. But I think, and I'm pretty sure even, that we can, once you have downloaded your files, you can change the projection, but it asks for some post-processing. So if you have any trouble to change the projection with your data, don't hesitate to contact us, and even maybe Neo could answer to this question. But so you can't decide in which projection the data will be downloaded, but I am pretty sure you can change it once the data is downloaded.
Okay, thanks a lot. The next question being a more technical question, what are the expected content and syntax for mandatory parameters enable map step Y and step X of the CAMS solar radiation time series? It's a precise question on a product, so I don't know if you know that.
Honestly, I don't really understand the question, so I don't want to say anything wrong. So maybe come to the user support chat as I've just shown, and we will be able to help you on that. But here live, I don't have the answer. Sorry.
I put also the question on the side, just in case. Um, okay, so next question. So very useful presentation. Thanks. Can we upload a shapefile of our study area instead of the rectangle you used to download data like the NGVI of your example?
Yeah, so that's a question that comes often during our trainings. So the answer is unfortunately no, but not for the moment. We cannot import a shapefile to download data inside this shapefile, but our internal team is quite aware that it's a feature often asked by users, and so we hope that this will be implemented in our tool uh, um, in the future, in the close future, let's hope. But yeah, our team is aware of that, and maybe it's already in the roadmap, but I don't want to say anything too promising. So yeah, we are aware that it's a quite often asked feature.
Okay, thanks a lot. The next question. How are the datasets served to the front end? What type of server API is used, for WEkEO?
Well, for the viewer itself, uh, I think it's WMS, but I'm not sure of this.
Yeah, I would
But I
say
guess
that also.
to display the data on the viewer, I think it's the web map service protocol. But then to download data, it's the HDA API. So there are two kinds of API inside the viewer.
Okay, thanks. Yeah, I think we also have this question quite often during the event also.
Okay.
So yeah, a classic. The next question, how can we cite WEkEO and or each layer, I guess, product?
So is my screen still sharing here?
Not for now, but we
Okay.
can cut the
Uh,
question so you can be able to
no,
show
it
something.
was just to show that we have an article in our help center. Okay, so let me share quickly my screen again. So if I go back to the help center, and if I type, for example, sites, I have one article left, quite convenient, and this article will tell you how to cite the WEkEO products. So I invite you to read this article. It is quite short, but basically, as I've shown here in the data viewer, you need to read and maybe use each license. Oh, I have an error. Just a few tips because I'm seeing here right now. When you have some errors on the viewer, you can refresh the page. Normally, it will avoid having errors. So let me. Okay, not for now. Maybe I shouldn't share my screen once again. But yeah, basically, I invite you to check our Help Center article. You have all the information in it.
Okay, thanks a lot. We put the link to the article on the chat also. So.
Okay.
Um, Next question, is there a limit to the number of free products I can download and or are all products free? So yes.
Yeah, so uh, maybe I could share also my screen, I don't know, but we have another article in our Help Center speaking about the quota limit. So every project of the WEkEO catalog is free to download. You only need a WEkEO account, but please be aware that there is a quota limit per hour. So basically, it's 100 requests per hour. So I invite you to check this article in our Help Center because you have more details. And if you have other and further questions after reading this article, please feel free to chat with us. But yeah, so all the products are free, but there is a quota limit per hour.
Okay, thanks a lot. This one, I think I also saw it a few times during the event. When I tried to find data in the data catalog, there is a text popping up, error querying the catalog, invalid credentials. What does it mean?
Yeah, so like we have seen here with me, also sometimes it could happen that there are some errors appearing. Uh, it's because, for example, as we are speaking now, there are some datasets that are resynchronized. And during this period, it could happen that some errors are popping up on our screen. The error querying the catalog invalid credentials, maybe it's another type of error. So if you still see this error and if it appears frequently, don't hesitate to contact us, and then we will open a ticket to our technical team to solve this issue. But sometimes, like I've just said, also refreshing the page could help because of this resynchronization. But yeah, if you still have this issue, don't hesitate to contact us.
Okay, thanks a lot. And we have time for 2 more questions, and then we will have to move on. So thanks for sharing. I want to ask about data generated. Is it done on a monthly or daily basis? If monthly, how can I get daily data?
Well, basically, it depends on the product. You have this information about daily and monthly often in the title of the dataset itself. And to answer to your last question, no, if it's a monthly dataset, you cannot get daily data. The opposite is possible. If you have daily data, you can calculate the mean by yourself. But if it's a monthly data, you cannot have the daily data. So I would recommend to search for your product of interest as I've shown during my presentation. And if you can't find your product, once again, don't hesitate to contact us and maybe we could help you.
Okay, thanks a lot. And we will go to the last question about the product you shown. What other variables are you calculating and analyzing? Does that include humidity and eutrophication levels as well?
So myself, I am calculating nothing, but no, yeah, in the catalog, we have, I'm pretty sure we have some data set about, providing data on humidity and eutrophication. I think if you type these keywords in the free text search bar in the catalog, it will filter some results and you will have some data sets left. Once again, if you can't and if you don't manage to find your product of interest, don't hesitate to talk to NEO first. Like sometimes, and no, most of the cases, it knows our catalog and it can help you on that. And if it can't, just come talk to us, ask to talk to a human, and we will be glad to help you.
Okay, thanks a lot. So
You're
that's it
welcome.
for the question. We will have to go to the next presentation, but for the few unanswered questions, don't worry, we will provide an answer in the post-event report. Thanks again, David, for your presentation. And yeah, so we can now go to the Jupyter Notebook tutorials. So welcome, Alexandre. And whenever you want, you can start sharing your screen and the presentation.
Hello, Gail. Thank you for the introduction. So I'm going to share my screen and start the Jupyter Notebook presentation. Okay, is it visible?
Yeah.
Okay, so hello, everyone. So my name is Alexandre Morin from Noveltis, and I will be presenting you this Jupyter Notebook on climate change. So today's topic is climate change, and this particular Jupyter Notebook will be focused on temperatures and droughts. So of course, climate change is a topic that you cannot avoid nowadays, especially when you study science. So as you know, it's mainly driven by human activities with the emission of greenhouse gases. And so we can already observe that it's already altering the precipitation patterns, temperature patterns, the frequency of extreme weather events, for example. And those changes are not necessarily happening all in the same way around the globe. And so this is what is crucial to understand and try to make predictions about future climate in order to anticipate possible mitigation policies, etc. So as I've mentioned in this tutorial, we are going to see the evolution of temperature and droughts. And for that, we are going to use climate simulations, which I'm going to present you in the next section. Those simulations will follow several different scenarios. So if you're already familiar with climate science, maybe you're familiar with the term RCP, which is a representative concentration pathway. So basically, those represent different scenarios of greenhouse gas emissions, going from 2.6, which is a scenario where climate is where greenhouse gas emission have been very mitigated, and to the RCP 8.5 scenario where no efforts has been made to mitigate climate change. So it's a best case to worst case scenario basically, and so climate simulation have been made under those several scenarios, and this is what we're going to see. What are the impacts in terms of temperatures and precipitations? So I've found this little graph here about different scenarios. So this is a summary of what I've explained to you. So 2.6 is a high effort on mitigation of global warming, and 8.5 is the worst case scenario with other scenarios in between. Okay, so this notebook works with Python. So if you're already familiar with Python, there are a number of libraries here that you probably already know. We are using NumPy, which is fundamental for processing Python arrays. Xarray is the most commonly used Python library to process netcdf data, which is the format in which the climate projections come. Matplotlib and Cartopy are used to draw the different maps and plots that we're going to draw in this notebook. GeoPandas is used to read and process geospatial vector data. So we chat geometries. And Rio Xarray is an extension of the Xarray library. It will allow us to combine the netcdf data to geometric datasets in order to crop the data to a certain area of interest, for instance. And so to use all of that, we recommend to use the WEkEO Lab kernel because it is here, because it has all those libraries already pre-installed. And one more thing is that in this notebook, so we are going to use climate prediction from the ECMWF platform. So it's available through WEkEO, but the original platform is this one. And to retrieve data from there, we can first use the traditional harmonized access API that David presented you before me, or the EarthKit library, which allows us to access the data in a more practical way. So this is not pre-installed on the WEkEO Lab kernel. So to have it installed, just follow this procedure here. So you just open a terminal. Take some time, yeah. And then enter those two commands to activate the environment and to install EarthKit within it. And that way, you will be able to import it in the notebook. So there is a dedicated article on EarthKit on the WEkEO website. So please feel free to visit it if you want to know more about how to use this particular library. So on my side, I've quite followed the same instruction. So setting up the cache for EarthKit. And afterwards, you will see how it works because I'm going to show it to you in detail. So to access the data, so I've already mentioned the library, but here is a brief overview of the products that we're going to use. So as I've mentioned, we are going to use climate simulations. So we're going to have monthly data, depending on the section, we're going to have monthly or daily data. For the monthly data, we're only going to use temperature. So it's temperature at surface. And for the daily data, you will see that we will use temperature and precipitations. So both of those datasets are available on WEkEO. So here's the dedicated page on the viewer, for example. Oh, I'm not logged in, so it probably hasn't displayed it the way, well, it doesn't, it's not it's not that serious. So, okay, so it's available on WEkEO. And we have monthly and daily data, both covering different periods. So we'll see how they are important. But basically, we're going to have an historical data set that will serve as reference, and two projections going from 2006 to 2100 for the monthly data, and 2056 to 2100 for the daily data. So now, in order to retrieve the and also, if you want to know more about what models are used and in which context, well, there are dedicated pages on the ECMWF website, which will explain to you in detail where those datasets come from. Okay, so now in order to retrieve the data, here's a brief overview of how I use the HDA API, which was presented by David in the previous presentation. So in this cell, it is just to set up your credentials in the .hdrc file. So if you already have one, this cell will not do anything. But if it's your first time using the HDA API, you might need to enter a credential that way. And then, as explained by David before, I have set up data request files in the JSON format by copying and pasting it from the WEkEO data viewer. So for instance, here, I can retrieve, for example, set up this request with the identifier of the monthly data set of climate projections. Here is the climate scenario that I have that I want to retrieve. So RCP 4.5. I'm retrieving the 2-meter temperature. Here is the model that I've chosen, the number of the simulation and the period, so 2006 to 2100. So this is quite what we were expecting. And using the traditional harmonized data access method, you can just, load this data and load it with the HDA client. And you can see that it has found one item, and then you can download it. So as we are working with climate data and we have several decades of data, I'm not executing the cells live because it would take quite some time. So I'm just going to go on. And then using EarthKit it's almost the same procedure, meaning that we use the same data request files in order to use EarthKit. So you can see that we still load the same dataset here. But this time, using the from source function from the EarthKit library, all we need to do is to enter the service that we're using. So it's WEkEO, the ID of the dataset. So it's still a projection on monthly single levels, and well, our data request file as an argument. And the difference here is that instead of downloading the data in your Jupyter, in your WEkEO user space, it will only download it in a cache and allow you directly to store the data in a variable and use it immediately as an X-array within the notebook. So here I've downloaded it using EarthKit. So I'm going to keep going because, well, it still takes some time to download. And here is the dataset that I've downloaded using EarthKit. So it's the temperature from the RCP 4.5 scenario. So you can see that it has several dimensions. So latitude and longitude, this is something that we were expecting, and time also. So you can see that time goes from here, January 2006 to December 2100. So this is consistent. Latitudes go from, well, it covers all the latitudes from minus 90 degrees to 90 degrees. And from longitude, they go from 0 to 360. And we have some other dimensions here, like this bounds dimension, and also in the variables, time bounds, lat bounds, land bounds that we are not going to use. And we're going to drop them because, well, it might yield errors in the future processing. And here is the temperature data. So you can see that it's a long time, latitudes and longitudes. And here is some metadata that you can read if you want to know more about the dataset. So in this first section, what I do here is that I show the evolution of temperature under the RCP 4.5 scenario. So basically what I do here is the pre-processing to drop the variables I've told you about. Here I wrap the longitude to shift them from 0 to 360 to minus 180 to 180 degrees, because it will be more convenient to work with than with Python and Matplotlib. And here I basically do a special average of the temperature data in order to have the global evolution of the temperature over time. And this is what the dataset yields, so from 2006 to 2100. And you can see that under this pathway, so RCP 4.5, we have a clear increase of the temperature over a century. So this is a result for one scenario, but let's compare it to the other scenarios that I've shown you before in this graph. So the 2.6, 6.0, 8.5, and see how the different scenarios evolve. So here you can see that I'm retrieving data using EarthKit once again, so with the same method, and I have written one request file for each of the scenarios using the same dataset, the same model, the same experiment number. They are all here available. I'm performing the same weighted spatial average here along the longitude and latitude dimensions. And then when I plot all the data, you can see that depending on the scenario, the evolution of temperatures is quite different. So here in RCP 2.6, you can see that we have a clear stabilization around 15 degrees on the global level. And the two intermediate scenarios have quite the same evolution. Perhaps it seems like the 4.5 scenario stabilizes at a lower level. And of course, the worker scenario keeps going up without any stabilization pattern by the end of the century. And one other thing I did then was to, so this is on the global level, but of course, humans and human activities are mostly located on land. So I've loaded here a land mask to study those evolutions, but using only data located on land. So with this function, I just crop the netsdf data to using the land mask. So here's an example at a random date in order to check that that the crop was a success. And if I do the same analysis using data located on land, I obtain this graph, which shows that, so in dashed lines, this is the land temperatures, and the plain line are the one that we had before on the global level. And you can see that on land, on each scenario, the temperature seems to rise faster than on the global level. And so what we see from this section is that, well, indeed, we have clear increasing patterns in temperature in high emission scenarios. But as this is only a global level, it is still quite hard to understand what are the actual concrete implications for human societies, human activities, and so on. So this is why now, in the next section, I'm going to show the computation of two heat and drought indicators, which are more concrete and which allows us to have a more evocative view on the impacts of global warming. So the drought indicator is the maximum number every year of consecutive dry days. And this T90P indicator is the number of days in a year where the daily temperature is above the 90th percentile of a reference period. So as you can understand, this time we're going to use daily data. And our reference period is the one I've mentioned at the beginning of the tutorial, the 1915-1999 period. And we're going to compare it to climatologies covering the 2026-2100 period. So same thing as before, we are using EarthKit and climate data request files to retrieve the data. As this is daily data, this will take probably a few minutes per file per data set to retrieve. So once again, I'm going to show them to you without actually executing the cells. So this time our dataset have exactly the same structure with those variables that we have to drop, and this time we have precipitation and temperature data. So we do also some pre-processing on the precipitation to go from precipitation flux in kilograms per square meter per second to total precipitation in millimeters. Well, in millimeters, because this is the unit with which computing the indicators is the most convenient. So here, with this pre-processing, we have our total precipitation variable. And those functions allow us to compute indicators, so the consecutive dry days and the T90P using the historical data as reference, and the other, and we are computing these indicators on the 4 scenarios. So this is a computation of the consecutive dry days in the historical data. Here is the T90P climatology for the historical period. And now, the first comparison, we're going to compute the indicators on the RCP 8.5 scenario, which is the worst case scenario, if you remember. So once again, retrieving the data, doing the pre-processing, computing the indicators. So this is the consecutive dry days. And now we're going to draw several maps of comparison. So RCP 8.5 versus historical reference data. So all those cells are meant to draw the map. And so in this first row is dedicated to the consecutive dry day indicators. So you can see that under the RCP 8.5 scenario, there are several areas that have very, very long droughts every year. I mean, it's an average, but you can see that in, well, of course, in this near Saharan there's desert, but also in Australia, Southern Africa, or here near the Amazon, which suffer from droughts. And here is the evolution from the historical reference period. You can see that in populated areas like here, the Mediterranean region, or here, Central to North America, you can see that the droughts are more intense than in the reference period, with a sharp increase in the number of consecutive dry days. But it is not homogeneously distributed. Whereas when it comes to the frequency of very hot days, it is clear that under the RCP 8.5 scenarios, they increase all over the world, but especially here around the equator, which seem very much hotter than either reference period. And the second comparison that we're going to make in this notebook. So I will see that I'm almost out of time, so I'll try to make this quite brief. It's to compare it to a mitigated climate, so the RCP 2.6. So basically, we're going to do exactly the same computations, so T90P and consecutive dry days, and draw the same maps here. So here is a comparison of consecutive dry days between RCP 8.5 and RCP 2.6. And you can see that here in the area we had spotted before, the droughts are much less intense under the mitigated scenario. So judging from the hint here, probably like 25 to 50% less intense, for instance. And here for the very frequency of very hot days, you can see that well, there is much less stress here on the equator than with the RCP 8.5. And when you compare the two, you can see that on the entire planet, the frequency of very hot days has decreased by a large number, by a large percentage. So this shows that, well, actions made to mitigate climate can have a real concrete influence. And so this shows the importance of the mitigation efforts for global warming and climate change. So we're reaching the end of this notebook. So there are a few exercises that you can do if you're doing this notebook at home, such as, well, trying to analyze the evolution of trends in temperatures on the ocean, for instance. We provided a mask for that. Trying to compare those maps with other scenarios, so 4.5 or 6.0. Use other extreme indicators, so other than consecutive dry days or T90P. Use other variables from the ECMWF, and you can also, focus your analysis on particular climate regions which are available. You can probably find a shapefile for them here. Those regions have been designed by the IPCC, or the Intergovernmental Panel on Climate Change. So you can also crop the datasets to such region to have a more focused area to study. Well, this is the end of my presentation. I hope you enjoyed it, and feel free to ask me questions if you have some. Thank you very much.
Thanks a lot, Alexandre, for the nice tutorial. It was really interesting, and obviously we have a few questions for you. So we will go to that part. The first one being, so you used your Earthskit during your tutorial. Is Earthskit reliable for analysis and detection of burn areas generated using Sentinel-2 images?
Well, I don't think Sentinel-2 is available using Earthskit. I think Earthskit is only dedicated to ECMWF data. I don't think that includes Sentinel-2.
Yeah, I would have also said it was for weather data and that type of thing, but maybe to be checked on internet. But yeah, I agree with you. Okay. Next question. Are the climate projection calculations done using an ensemble of climate models or a single specific model?
In this case, I've selected one single specific model. So if you visit or if you try to download from WEkEO, you can see that it will propose you several different models. So I've chosen one quite arbitrarily, but there are a lot of them to choose from.
Okay, thanks a lot for the clarification. Next question. How would you go about downscaling climate projections so they more accurately represent local climate change?
Well,
open question.
Yeah, well, I've quite mentioned at the end of the tutorial that you could always crop the datasets to well, climate regions that were defined by the IPCC. So this is, I mean, those are each region has quite a typical climate, like Southeast Asia, Mediterranean, or the Amazon area. So would probably do a separate analysis for each of this region, which I'm interested in, to have like more local views on the impacts of climate change.
Okay, thanks a lot.
And for example, for the Mediterranean, the impacts of the droughts, it's quite higher, and it's quite, well, significantly different than in I don't know, Southeast Asia, for example. And that's quite obvious to check. Yeah.
Okay, thanks a lot. A question about the type of files you used. Why using JSON instead of netcdf file? Is the JSON faster to download than netcdf, or what's more important?
Okay, I don't. Perhaps I wasn't very clear when I explained that. So the JSON files are only request files. They only contain the request to the WEkEO platform, but when executing either the HDA API or Earthkit, it's a netcdf that will be downloaded.
Okay.
So
okay,
JSON
thanks.
contains only the request to the netcdf, which is downloaded for the notebook.
Okay, thanks. Another question. more about the beginning of the notebooks. The acronyms for the parameters are hard to comprehend. Is there a place where the complete name is shown?
Well, there are several acronyms. I'm not sure which one you're talking about. If it's about the climate indicators like CDD, which is consecutive dry days, and T90P, which is the frequency of days where the temperature is above the 90th percentile of the reference period. So those are taken from there is a dedicated article which lists lots of extreme weather indicators. So I've taken those acronyms from that page. There is a link in the notebook if you want to visit it and well, have more details about them. And probably I was for the RCP scenarios, for instance, so representative concentration pathways. It's true that I've only mentioned it like once in the beginning of the tutorial and then not again, so perhaps it was also confusing. I'm sorry about that.
Thanks a lot for the clarification. So we will do a few more questions of this one. When you store data directly in variable on the Jupyter lab, how maximum memory can you use?
I don't know the exact number. Perhaps that's more for the user support. I know that I tried to delete the variables when I've done using them because with climate data, the files are usually pretty big. So in order to save space, I try to do it, but I don't know exactly the number of the memory size that we are allowed in WEkEO.
I don't know. I don't know either actually, but I think we can find an article. I will check. We put the question on the side. Okay, a general question. How much time does it take to execute all the code you showed?
Well, what takes the most time is the retrieving of the data sets. For the daily data, at the end, each earthquake request can take I don't know, 2 to 3 minutes. So I don't know, if you do a run all on the notebook, perhaps it would take I don't know, 20 minutes, I would guess, because the other processing is quite quick. It's mainly the data retrieving that causes trouble.
Okay, thanks a lot. So we have time for, I think, 3 more questions. Why did you use CMAP5 instead of a more recent data like CMAP6 or CMAP7?
I've used this one because this was the couple intercomparison model available on the WEkEO platform, but I'm aware that there are more recent ones.
Okay, thanks. Yeah, so we have to update.
I think CMAP5 is the only one available on WEkEO for now.
Yeah, a few updates are still needed on the data catalog. Is your working environment on WEkEO GPU?
I'm using the WEkEO Jupyter Lab, using the Earth observation tools. So I think I'm using the basic WEkEO installation.
Okay, thanks a lot. So we will have time for one more question, I think. Why did you use both precipitation and temperature for the daily data, but only include temperature in the monthly data?
Yes, in the section where I was using monthly data, I was only using at the global evolution of temperatures. So I only needed to retrieve temperature data. And in the sections where I use daily data, I wanted to compute drought and extreme heat indicators. And in order to compute the consecutive dry days indicator, I had to use precipitation data because a dry day in this indicator is defined as a day where the total precipitation is under 1 millimeter. So this is why I needed the precipitation data and the temperature data to compute the very hot days indicator.
Okay, thanks a lot for the explanation. So we will have to stop there for the question about the notebooks. Thanks again, Alexandre, for the presentation and the question. For the unanswered question, we will provide an answer either in the post-event report or by writing on the question you ask. So don't worry if your question hasn't been answered. We will now take a short break. So yeah, feel free to look at the poll, grab a coffee, and we see you in a few minutes for the rest of the tutorials. See you. Sorry, I had an issue with my microphone. Welcome back, everyone. So we hope you had time to take a little break, and we will now go to the QGIS tutorial with Daria. Welcome, Daria.
Hello. Hello, everyone.
And whenever you want, you can start sharing your screen and do the presentation.
Okay, thank you, Gael. We'll start sharing it. And here we go. Do you see it?
Yeah, yes, the screen.
Okay. So hello, everyone. My name is Daria. I'm from Novelties, and well, today I'm here, as already been said, to present you a QGIS exercise dedicated to impacts of climate change on freshwater resources with sentinel-2 imagery. So for this tutorial, we decided to focus on one specific area in southern Spain, because, well, southern Spain is one of the regions in Europe which is mostly exposed to the effects of climate change, and specifically to the effects of climate change on water scarcity. And, well, I don't have much time to give you all the context, but we decided to focus on the Doñana National Park. It's in southern Spain, not far from Seville. And here on the slide, you can see a little image, which is a bit sad, honestly, because here we can see a photo of Zailio Pond in this national park, and we see this one image, like a photo on in the middle. It's a photo of this pond in June 2011. And the photo below is in October 2022. And you see that, well, in the first photo, we see water. And on the second one, we see basically nothing. It's just a field. And it's quite sad. And on top, you see a small image, a small plot with depth of this lake, this pond, from 1994 till 2022. And you see that, of course, it fluctuates. Yeah, it's also wetlands, but wetlands doesn't mean that it's the lakes, the ponds there doesn't mean that they always are full, always like deep. It's quite shallow lakes by their nature. But you see that with time, we have a very, very low values of depth, and sometimes well, we see that it goes more and more below this red line, which marks the bottom of a pond. So for this exercise, for this tutorial, as I said, we will use sentinel-2 imagery, and most precisely, well, we will use this product from WEkEO platform. And we downloaded only NDWE product. I will show you very quickly. Well, I need to identify myself. Oh no. Yes, okay, great. So you can choose a product here. And yeah, we were looking at water index because we're more interested in water index to see the freshwater sources. So in this product, there are only bands that are used for water index calculation, which is band 3 and 8. And the second product we're gonna look at is this EU Hydro river network, which has basically, you can actually see it here on the WEkEO platform with all the rivers, with all inland water and coastal water as well. So let's go straight to the project itself. As I don't have much time, I'm not gonna be very in detail. The step-by-step procedure is explained in the video and in a PDF file for this tutorial. And well, quickly saying about the exercises. So first is to work with satellite imagery. So each image is represented as a raster tile. And what we downloaded basically two tiles. So our zone, I will show you very quickly without. So this is basically, you can actually see the national park. Basically all this zone, here you can see the river. Here's some quite strange, well, it is water, well, depends also on when this image was taken. Also water here. And to cover this zone, we need two tiles with SQA and SQB of 2029. So we downloaded 2 tiles, as you can see, for 2018 and 2022. Like, we wanted to see what's the change between 2 dates. Because we know that, for example, in 2022 was a very, very hot year with a lot of heat anomalies. And here, for example, you see the band 3, as I told you, and we also have band 8, which is a bit in different colors. And we have the same for 2022. I will not, I'll show it like this, you see. And well, we download 2 separate tiles, and for our further calculations, we wanted to have like basically one big one. So for that, we merged our tiles. So for example, we have one merged one for band 3, and the same for band 8, and the same we have here for 2 bands for 2022. And to merge, we use, well, we go to processing toolbox here. If you don't have it open, well, it depends on your QGIS settings. If you don't have it, you can see it. Well, my Zoom panel covers it, but here on top there should be a little it's here like this gear icon that gives you access to this toolbox. So when you search for merge, you can see merge vector layers. It's here in vector general, and here you basically choose among layers which you want to merge. Sorry, actually, no, I went a bit too quickly. It's not merge vector layers. We work with rasters. It's this one. Sorry, there are 2 different tools. So this one, yeah. Here you choose raster layers, and then that's basically it. It just merges it, and also rescale to unify the scale bar. After that, well, you see that it's a big image, and as it's a raster image, it's a Sentinel 2 image. It has a lot of pixels that has quite a high resolution. It also means that it is bulky. So to process it further, we would like to clip our image to the only area of interest, so around this national park, because otherwise, like even with this amount of information, it already can some processing can take time, and by clipping, we actually reduce this time further. And also, yeah, we just don't really need anything else, any other areas. So for that, we have it clipped. For example, let's see. Okay. So we just clipped this. It will load. It just needs a bit time. Yeah. So original image was this. Yeah, you don't see it, but because it's the same area. But yeah, you can see that when we clip it, it is a smaller area. We could even clip it even smaller, but we decided to stay on that. And to clip, there is also a clip function, and there's also for vector, which is important to use for rasters, and one for raster, which is, I think it is which one? Clip raster by extent. Yeah, this one. So here you choose the layer. For example, we choose the merged one, and then clipping extent. You can either use some map canvas extent or just calculate it from layer. You see, like we're proposing layers you already have, or you can literally like choose it yourself, like type it yourself. So after we did that, we now have our clipped layers for both 2022 and 2018 for both bands 8 and 3. And next is, of course, to calculate the water index, which is band 3 minus band 8 divided by band 3 plus band 8. I hope I did not miss. Yeah, I think it's, yeah, minus on top and plus, yeah. So, and for that, you can use raster calculator. You can put calc, and there's raster calculator function, which is here. You can put an expression, and you can choose it yourself, like this, blah, blah, blah. Or we also provided it with, I will show you, it is provided in a PDF file we are giving to you. So that's a formula we used. So we have band 3 minus band 8, and all that divided by the sum of these 2 bands. And we also added the condition more than 0, because for water index, basically the the pixels that are having values, well, the pixels of water index that are having values more than 0 usually represent water, and when negative ones or very close to 0, they are representing something else. So like this, we just did 2 steps. We calculated NZWI and also filtered it to have a binary representation. And as a result, we have this image. So as I told you, you see we have basically in black is whatever it is, and in white is all possible water with like sea and stuff. And we did it for both years, and even if we just compare it visually, we already see that in 2022, I will zoom a bit. In 2022, we already see that the amount of white pixels it has reduced. You see that there are less pixels, and more importantly, we know that here there's this national park, and if we look at 2022, well, it's not like we really see water there, and in 2018 we see all these little ponds, lakes, the wetland itself. Next, what we want to do is to find more like we visually detected that there were less water in 2022 and 2018, just in 4 years. We wanted also to have evaluation more like in quantity-wise. So for that, we need to calculate the area of this water present, water surface. But for that, first we need to vectorize our raster image, because this is still a raster image. So if you really like zoom in, you'll see that it's pixels, and we need to make it like transfer to polygon to make it vector. And for that, there is a tool here in this tab, raster conversion polygonize. Here you choose your input layer, which is raster. Then you, yeah, these two are not very, very important, and you save it as a new vector layer. And for example, we look at 2018, and we see now it is not a raster, like it's not an, I will untick this one. It's not pixel. You see that it's a polygon, like this one is one big polygon, this is another polygon, and so on. And it is already filtered. You can see that there's a filter to basically show only water, because we are interested in water index and water bodies, so we don't need really the full image. But if, for example, we click on this filter and we remove this filter at all, we will see that it's exactly the same kind of like we had a raster image, and it just transferred it to polygons. And yeah, you also might see that it's half transparent kind of, because we reduce the transparency to have a better view here. So that's basically it. And I will right click, go to filter and put up, no, not this one, sorry. Okay, I think my QGIS, yeah, okay, well, we need to wait a second because it's a bit, yeah, it doesn't like something. Well, the thing is that before we moved to see the difference between two, we wanted to calculate the difference between the two dates, the water index of 2 dates. We need to fix the geometries. That's very important because, well, we see that it's something is good and a layer is completely okay, but some, okay, it's finished. But it's only for our eyes, but not always for like the processing itself. So we need to fix the geometries, which you also can do here by putting fix here. You just fix geometries, basically like removes all the instabilities, let's say. Okay, I'll just filter it very quickly. Okay, and after this, after the geometries are fixed, we can have a difference, which we calculated already. This one actually takes a lot of time because there's a lot of small polygons which were going to be compared to each other. And this is basically made by using symmetrical difference tool. Don't remember where's the, okay, it's here. So basically you choose 2 layers, vector layers, to overlay them and to see, to basically symmetrical means that it extracts the portions, like it's written here, or features from both the input and overlay layers. They do not overlap. So basically that the parts, for example, here you can see all the polygons that belong to 2018 but don't belong to 2022. So basically exactly the difference, which means that all these water polygons we see here, they disappeared by 2022, or at least that's how Sentinel imagery, Sentinel-2, says it, because of course depends on the quality of the image, quality of the water, if like some turbidity or some whatever. Of course, there might be still some water, which just the way satellite sees it, it's not exactly, well, it doesn't see it as water. And here in the difference, if we right click and we go to open attribute table, we see an area column, which we added by using this field calculator function. And here you can see the area in square kilometers per polygon. It was sorted from biggest to smallest. You see, for example, that the biggest one area like 8 square kilometers. If you right click and flash feature, you will see which one, and it's this one. But that doesn't really give us much representation because, well, it's just each small polygon having its own area. And to have quickly have like a sum of all these areas, we can go to sorry, I think it's view panels. Yes, view panels, and we have statistics. This one. And here you can choose the layer you're interested in. Because we already were looking at this one, it automatically chose this one, and also area. You can choose all different fields, but we are interested in area, and you can see the mean, median, maximum, minimum as well. But we are interested in sum. And here you see that it's 65, a bit more than 65 square kilometers, which is just for the scale, that's around 9,000 football fields, which is quite a lot. And that means that all these 65 square kilometers of fresh water in this national park disappeared in 4 years. And it's also important to note that this wetlands, this national park wetlands, there is actually quite important ecosystem in whole Europe. It's a home to many animals, many species, which are also endangered. So you see that that it's kind of how entangled all that together. So that was for the imagery, and as well we wanted to see a second product, as I told you, is EU Hydro River Network, which is basically kind of a base layer. So it's a delimitation of water bodies, and we used in this tutorial we use it more like as reference layer to say like, okay, what it could be with all the water present, let's say, and to compare to what we have in 2018 and 2022. And of course, with this delineation, it's quite well, it depends on when it was taken. It's quite how to say, like generalized, so it's not a very like exact representation. I just wanted to see like correlation between the two. So when we added those this new product, Hydro, it's these three. Actually, when you import the layer, it has many layers, but we only like sub layers. We chose only 3. So pink is inland water. Yeah, green is some river network, and purple is transit, which basically means that, well, it's still water, and you can see that it's a river, but it also means that the flow, the level, water level in this for this transit water depends on the tides, because, well, it's on the coast. So after we had it all free, we merged it to have one layer, basically, because we needed to like more clear representation. And so that we used this tool, which I already showed you, merge, but for vector layers now. And then if you zoom out, you see that it's actually the whole not Spain, it's the whole river basin of this river, and we're not interested in that, so we clipped our zone only to that. You see, it's only in green, but are more in our area of interest. And to that, yeah, you clip by extent, basically the same as we did for raster, but now it's it is extracted by extent for vector layer. And if you click on it, you can have an extent which you can put yourself, but we also chose an extent which we computed from one of the like water indexes layers. And that's it. And we wanted to do exactly is to see the overlapping of this EU Hydro product with Sentinel-1. So Sentinel-2, sorry. Sentinel-2 1. And if we do that, we can see that this is, for example, I will also drag and drop this one. This is from 2022, and this is our base layer, as we say, our reference layer with all the water that's supposed to be there. Here in green and in purple are the 2022, and we see that, well, yeah, exactly, like a lot of areas water bodies are missing. But this one we don't really look at because, well, it's a bit overestimation regarding the tides. And the same for 2018. You see that overall, yeah, we see the still there are zones missing comparing to the reference layer, but we see that it's much more water present than for 2022. And that's it. That was quite quick. I hope you had enough time to just at least see something. And yeah, again, you can have a full tutorial, and you can slowly, step by step, follow it yourself on your own time, because the video and the file and all the project full of files as well provided to you on the website. So yeah, I hope you enjoyed it and learned something new. So if you have questions.
Thanks a lot, Daria, for your presentation. It was really interesting. And for now, we have a few questions for you concerning the tutorial. The first one being a more general question. What type of resolution can you achieve through QGIS?
Well, it does not depend on the software itself. It depends on the products you use in a QGIS. And well, for example, here we used Sentinel-2 image, so we have a resolution of Sentinel-2. EO doesn't have a resolution itself. It's basically just a delineation, basically the contours of water. But again, yeah, it's not QGIS that gives you like a resolution. It's, well, the product you are using.
Thanks. Okay. Another question about the resolution, we will say, can the users analyze pixel data with the help of MATLAB as well in integration with QGIS?
About MATLAB, I cannot tell. I don't think so, but I'm not sure about that. But I think no. But we have Python. QGIS has application in Python. So, for example, there is a Python console in a software itself, which you can use to write your own short scripts, some functions. And also, if you go to when you use some function in QGIS, whatever function you use, you can see also behind that there is a script, there is a code. So basically, it's all relied on Python. So with Python, yes. With MATLAB, I'm not sure.
Okay, thanks a lot. Okay, I will maybe put it on the side just in case. A question about the plugin. What are the advantages of using the CMEMS NetCDF plugin compared to other NetCDF plugins for QGIS?
Well, this, I guess you're talking about the plugin that we actually developed here in Novelties for Mercator Ocean. And what is good about this plugin is that it allows you to see the structure of your NetCDF before you insert the data itself, because, well, NetCDF is like multi-nested kind of multi-level data, right? So it has like quite a complicated structure. And some plugins, or like, for example, default option in QGIS to add it, it's sometimes not very representative, especially because you just see the layer. For example, you just see the variable and that's it. And then when you add variable, I think it usually adds as a, for example, if it's a raster, it adds as, well, NetCDF is raster, yeah. It adds one raster layer in which there are several bands, and each band corresponds to the time frame, which means that you need to add to a project this layer several times, and in each choose your time frame to switch, which is not very convenient. And in this plugin, you open it, you see all the variables you have, you see each variable. For each variable, you see the time frame, so you can choose the time frames. But also, for example, depth if it's for like water or like air column, and like this, you can choose which exact data to add, because if you add the whole like time frame, for example, the whole year, it means that you will have so many bands and you will use only, I don't know, 10, which is not very convenient. And with this plugin, you can actually choose only the data you really need, and you also can add several variables for example, if you have several variables and you need the same time frames, you can add them like very quickly. So it is very useful tool for that.
Okay, thanks. So a very useful tool.
Yes.
Another question, can we apply the same method to snow cover using NDSY?
I would assume yes. I'm not familiar with this snow index, but I assume as soon as you have bands that are needed for this index, to calculate this index, and you calculate it, well, you have this representation, as you saw, with water index. I think, yeah, from that, it's more or less going to be the same procedure, yeah.
Okay, good to know. Thanks. So here we have two questions. The first one being, did you calculate the average for both the 2018 and 2022 imageries to reduce bias? And two, does the index you want to calculate tell you which bands you need?
So yeah, for first question, yeah, I forgot to mention it. Now it is mentioned, of course, in a file, PDF file. I just forgot because of a lack of time. We chose only the mid-July of each year of 2019 and 2022, because we know that, for example, 2022, July and August were the most hottest months with most anomalies, and yeah, the summer 2022 was very dry for many areas, especially for southern Spain. And yeah, and for that we also chose 2018. Like in 2018, we chose the same date. And yeah, to reduce bias, I mean, for that you would need, that's a lot of processing. That's a lot of pre-processing to like have a average of each band of for the like 2 tiles. It's gonna be a mess. Yeah, it's really a lot to process. And for the second, does the index you want to calculate? Well, not on a WEkEO platform, I don't think so. But I mean, if you need it, you just Google like water index, for example, right? And it gives you which bands to use. There's also like vegetation index, like snow index, and so on. So this information is like out for free.
Okay, thanks a lot for the explanation and the answers. Okay now. What methods were used to validate these results? So,
well, that's not like it's very, let's say, high-end results. It's just to show you how to use different products of WEkEO platform in QGIS, and also like how to work with different type of data, for example, raster images and vector files. And well, validation here, it's just to like compare with what we have, like compare the in situ data, because well, EUHydro is it's relying on in situ data and comparing with satellite imagery. So that's just comparison. But yeah, of course, to validate it, you need much more data, much more analysis, more in-depth processing also.
thanks a lot. So we have time for a few more questions. I have seen the hydro area is only in Europe. Is there a possibility to scale it up to the entire globe?
Well, no, because this product is only for Europe. And as I said, it is based on in situ data. So, I mean, it's not like you can really like propagate it to the entire globe for that. So no, unfortunately, no. But maybe there are other products that are covering specific zones in other places on Earth, or maybe will be, I don't know. But yeah, it's true that this one is only for European Union, yeah.
Thanks. Yeah, so we will do 2 more questions and then we will go to the next presentation. Is it possible to visualize in 3D? I think in QGIS.
Yeah, I don't think so. I mean, you can, for some variables, for example, if your variable is not flat, you know, so for example, here we didn't use variables like that because we have raster image, which is flat. But if, for example, you have, I don't know, temperature, like air temperature or water temperature, it is not flat because it's not only on a, well, on a flat surface, but also in a vertical dimension. You cannot really visualize it. I don't know, like what you mean exactly by visualization, but there are some functions in QGIS I know that allow you to make plots or like distribution kinda in 3D. Yes, but there are not many. I don't think there are many because, well, it's yeah, that's not not the point of this tool, I guess.
And the last question, how to use symmetrical difference to identify increasing and decreasing areas simultaneously?
That's a good question because, yeah, it's true that when we use symmetrical difference, it means that it extracts polygons with zones that are not overlapping. So it means that, yeah, it means that either it decreased or increased. Like, yeah, so it's either like present day 2022 and not present 2018, or vice versa. And for that, I think for that it's not, maybe, I'm not sure, but I can look. But I don't think it's symmetrical difference. There's also there's difference, there's symmetrical difference, there's intersection, and I think for that, yeah, only symmetrical difference is actually good. Or maybe actually there's difference. Yeah, maybe you can use difference. I don't know. I didn't use that, but it seems like difference, just difference tool in QGIS might work because it extracts only like features from the input layer that fall outside or partially overlap with the overlay layer. So maybe you can use this tool and see, and also like exchange like input and a layer and overlay layer. So for example, you compare 2022 to 2018 and you will have one result, and 2018 to 2022, it could be different. It could be different. And like this, you can see if it is decreasing or increasing. That's what I can say very like like very quickly, but maybe there are more precise tools for that also in a QGIS, or there also could be some plugin which can add some functionalities.
Okay, great. Thanks a lot for the explanation in the live research. Thanks. So we will stop there for the questions. Thanks again, Daria, for the presentation and the tutorials. And yeah, now we will go to the last tutorial of the day, so the RStudio tutorial. And yeah, so Simon, whenever you want, you can start sharing your screen and begin the presentation. Welcome.
Yes. Thank you. Do you see my screen?
Yeah.
Yes. Okay, thank you. So hello everyone. My name is Simon Millet. I'm a scientific engineer at Noveltis. You will for this training we will see the tundra wildfire in Siberia in 2020. So you will also have a closer look of WEkEO's products, their structures, format, variable, and how to explore and plot them. So first, we will explore the netcdf file. Then we will make a basic plot of carbon monoxide. Then we will visualize carbon monoxide at a single point. Then we will compare the result with concentration of nitrogen dioxide. And finally, we will use the Sentinel-3 data to see two images before and after wildfire. So this training focus on tundra wildfire in 2020 in Siberia. So during the summer, Siberia expressed massive wildfire, mainly due to extreme climate condition with high temperature exceeding 48 degrees and prolonged drought. And the wildfire is not a typical forest fire because it affects the tundra fragile ecosystem that is usually not highly flammable. And so during this training, we will allow to see the evolution of wildfire during the summer 2020 with the mass concentration of carbon monoxide and nitrogen dioxide. And finally, we will use an observation product, two images of Sentinel-3. So first, the Jupyter notebook must be set up with all necessary libraries. So for this training, we will use 8 libraries. So there is ggplot2, it is for creating graphic. Dplar, it is for manipulating data. RColorBower, it is for color palette. NetCDF4, it is for manipulating NetCDF file format. QGIS, it is for arranging multiplot in a single page. Hybridate, it is for date time data. And raster is a package for reading and manipulating spatial data, especially for using for Sentinel-3. So first we load all the libraries. If you do not use if you use another support, you can copy this line to download the whole libraries. So for this training, we will use WEkEO's data. So the data are already downloaded in the folder data here. And it was downloaded in the WEkEO Viewer. You have a link here. You can explore all the products. So for this training, we will use 2 different datasets. First, it is the CAMS global reanalysis in Siberia area. The elevation, it is at 1000 hectopascal. That is close to the ground. And the variable, it is carbon monoxide and nitrogen dioxide. And it was a daily means between these 2 dates. And the second data, it is a Sentinel-3 image for 2 dates in the 8th of June and in 27th of June. So for this training, you don't have to download it because the file are already downloading. But if you want, it is possible. You have whole information about the dataset. You will need to have your own WEkEO credential, username and password. And if you have not, it is possible to creating in this link here. So first, we set the path of the NetCDF file. We load the NetCDF file, and you can see here all information about the NetCDF file. So there is one variable that is carbon monoxide here. And here you can see the dimension, so the time, the pressure level, it is only 1, the latitude and longitude. And here it is the global attribute to have more information about the dataset. So first we load all the variable. You can have information about, for example, carbon monoxide variable. So the dimension of variable, and so it is longitude, latitude, and time. And here the value for longitude, latitude, and one time. It is possible to do the same for time, but you can see here it is a number, not a date. So in R, we should convert the number to a date with this function as POSIX. You put the time variable and the origin. The origin is noted in the information of time variable. It is units here. It is since January 1970. Okay, so we run the sale, and you can see now it is a date, not a number. So now we make a basic plot of carbon monoxide. first we determine the figure size, then we create a data frame for the index of time. So we should choose here the index time equal to 7, but you can choose over index time. And it is possible to visualize the data frame that is depend of longitude, latitude, and you have carbon monoxide. So now we make the plot. So we use ggplot function. Then we put geom tile where we put all the data, so the data frame with the column of longitude, column name of longitude, latitude, and carbon monoxide. Then we select the color scale option. After it is aesthetic option, so general aesthetic option here, title and subtitle. Here it is for legend and the size of legend. And then we save the figure in the folder figure here. And then we plot the figures. So here we can see the mass of carbon monoxide for this date. We can see a very high concentration here of carbon monoxide. It is around longitude 150 and between latitude 65 to 70. So it is due to wildfire. So now we will see the carbon monoxide at a second point. Because in the previous figures we saw a high concentration of carbon monoxide, especially at this point. So first, about the dataset, we create a data frame that depend only on the time. So we find here the index of the nearest coordinate of this coordinate. And the nearest coordinate, it is this one. So we have the index here. We do the same for the time between June to the end of October. And now we create a new data frame with the carbon monoxide dependent only on the time. Because we choose one index of longitude and one index of latitude. So we can see here the date and the concentration of carbon monoxide. Then we plot the time series here. So we use a geom line. And here it is a general aesthetic option. And we can see the mass concentration of carbon monoxide between from June to the end of October. And the figures show the high concentration of carbon monoxide, especially from May-June to the beginning of July, and a high concentration at the end of July, likely due to wildfire. So now we make a comparison with nitrogen dioxide. So nitrogen dioxide is an atmospheric pollutant that serves as an indicator of pollution from road traffic, industrial activity, and biomass combustion. Because of there is no significant human activity in the study area, the observed nitrogen dioxide levels are likely due to biomass burning. So for this part, first we load the netcd file. It is the same code that we have seen before. We find the index of the nearest coordinate. It is the same coordinate than before. we find the index of time, and we create a new data frame of nitrogen dioxide. You can see here. So the data frame depends only on the time. And finally, we merge the two data frames. So for this, we create a new data frame. We put the data frame of carbon monoxide, and we joint by date the nitrogen dioxide data frame. Up. And here you can see the date and the concentration of carbon monoxide and nitrogen dioxide. So now we can plot the time series. So we use gplot, and we put two lines of geom-line function, one for nitrogen dioxide, the second for carbon monoxide. So here you can see the concentration of carbon monoxide and nitrogen dioxide. So the figure reveals a strong correlation between the two indicators. So together, this indicator can be used to identify wildfire. But we can see here a peak of nitrogen dioxide, but not in carbon monoxide. It is it is due to more efficient combustion in the tundra vegetation, resulting in less carbon monoxide and more nitrogen dioxide. Additionally, the longer atmospheric lifetime of and higher mobility of carbon monoxide might explain its lower local concentration. Okay, so now we will see Sentinel-3 data. So Sentinel-3, it is a satellite. So we will see two date, two image. It is before wildfire and after the wildfire to see the difference between the two images. So it is different to map satellite image. So first we open the netdf file. So there is different bands. S3 it is for red, S5 it is for green, and S6 it is for blue. So we open the three bands. Then we extract the radiance of variable of each netdf file. And then we convert in a raster object, then thanks to the function raster. And we improve the image visualization with stretch to improve the contrast of the image. And then we create the RGB image. So we put all the band in a single variable, thanks to the stack function. And now we plot the RGB image. So we put the output file here. We open the PNG graphic and plot the image. And then we display the image. So we can see here the image. So there is white, red, and green in the image. That is for cloud. But that is interesting. It is this area. We can see some patch here, but just one. So now we will look at the same image 20 days later to observe the change. So it is exactly the same code, but for another date. And you can see here the image. So we can see a whole many patch here, here, that is not seen in this image. So the patch is it is a burn area. So during these 20 days, there is you can see the burn area, and here it is a fire that is always active. So Sentinel-3 satellite allow us to visualize the extent of wildfire. So now the training is finished. If you have a question, do not hesitate.
Thanks a lot, Simon, for the presentation. We have a few questions for you. And I think people were trying to do the tutorials at the same time as you, so we will probably have a few questions later also. The first one being, I think we often have this question, why did you decide to present your R tutorial in a Jupyter notebook?
Yes, I prefer because it is you can have many text and code in the same page. It is more useful, I think, for presentation. But it is possible to do the code in the in RStudio. There is no problem.
Okay, thanks a lot. This one, a very nice presentation. Can we use this tutorial to study other areas or adapt it for other gases emissions?
Yes, of course. You can use this training, for example, to have an example of creating a map. And you can study, for example, emission of greenhouse gas near the city in Europe or Asia or everywhere you want.
Okay, yeah, as long as there is data, it should be fine.
Yes.
Okay, thanks a lot. Then we have this question. I think I can answer it also. Where is the Jupyter notebook file located? I couldn't find it on the Jupyter Hub in the public folder. So for the tutorials on WEkEO training, for the tutorials to be available on the Jupyter Hub, it needs to be synchronized with the WEkEO GitHub. So right now, this action hasn't been made by the user support. So you can only find the tutorials on the webpage of the event, but at one point it will be available on the public folder if you want to take a look later. Okay. And yeah, if you have questions about the notebook on the public folder, don't hesitate to contact the user support also, of course. Another question, this time about the tutorial also. How is carbon monoxide data visualized in section 5.2?
Okay, in section 5.2, it is a visualization of carbon monoxide at a second point. So we have the data set with the concentration on carbon monoxide, but dependent of latitude, longitude, and time. And for this section, we select the one longitude, one latitude, and carbon monoxide dependent only on the date. And then we use geometry to put to create a time series of carbon monoxide.
Okay, thanks a lot for the explanation.
Yes.
And yeah, I think there is more detail in the tutorial also, obviously.
Yes.
Okay, thanks a lot. So I think that's it for the question. So thanks again, Simon, for the presentation
Yes.
and the
Welcome.
tutorial. And yes, thanks again to everyone for their participation of today. So I'm just going to okay, so okay, I wanted to pull the survey on the screen, but it doesn't work. I don't know why. Oh, yeah, okay, it should be fine now. So yeah, thanks again to everyone for their presentation and to you participants for joining us today. So we hope you found the session useful and informative and that you could learn a bit more about what is WEkEO and the data available on it. So before you leave, I just want to remind you that there is a section on the website next to the Q&A reserved to the poll. So if you haven't done it already, we would really appreciate to have your feedback on today and what we could provide in the future. Finally, concerning the replays, the presentations, and the certificate of attendance, they will soon be available and you will be notified by email, so keep your inbox closed. And yeah, thanks again to everyone for your presence, and we'll see you during the next training. Have a good day. Bye.
Thank you, Gail. Bye, everyone.
Thank you. Bye.